just wanna party tonight. Somewhere crazy, lose myself in the lights. I just wanna go.
Let's introduce our formulas today. Now, let's start with the formula for work done. The formula for work done says N over M minus 1. V1 minus V4 plus bracket. Over P plus bracket to power N over 1 minus N minus 1. Yes. This is your formula for work done. The same formula that you're given for work done is the same formula that you use to calculate power. Are we together? The same formula for work done is the same formula for power. The only difference is that now you multiply with the rotational frequency. Are we together? Just make sure your rotational frequency is in revolutions per second, not per minute. Okay, next formula is volumetric efficiency. These are our two formulas, V1 minus V4 divided by V1 minus V3 multiplied by 100 to get it into percentage if you want it as a percentage, or if you just want it to be per unit, don't multiply by 100. Are we together? Can you read it for me?
17.3. A single stage, single acting, reciprocating air compressor has a bore of 210 millimeters and a stroke of 290 millimeters. It runs at a speed of 550 rads per minute. The clearance volume is 6% of the swept volume, and the polytrophic index is 1.35 throughout. Intake conditions are 97 kilopascals and 19 degrees Celsius, and the compression pressure is 600 kilopascals. Determine the free air delivery in cubic meters per minute. Open brackets on that A, it's got free air conditions 101.325 kilopascals and 15 degrees Celsius. In B, the volumetric efficiency referred to the free air conditions. C, the air delivery temperature. And D, the Psychopath.
Okay, so let us answer these questions together. So first of all, they want us to calculate the free air delivery, or they want us to calculate the volume of the air that is going to be delivered. Are we together? Now, the funny part is, if you remember the last time, we calculated V1, V2, V3, and V4. Are we together? And none of those is free air delivery. Do you still have the calculations from Wednesday? You still have them? Now you're scared. 2 comma?
2.324 times 10 to the power negative 3.
That is awesome. That is correct. Okay, now that we've got our values for our V1, our V2, our V3, let us answer the first question now. Calculate the free air delivery, right? Calculate the free air delivery at 101.325 at 15 degrees Celsius. Now, they've given us the pressure that they want us to calculate, the volume of the air that you're delivering, and they've also given us the temperature at which this volume is going to be delivered. Are we together? Okay, now what we have is we've got our intake conditions and we've got the delivery conditions that they're specifying out here. Are we together? These are the delivery conditions that they're telling us, and then what we have is our intake conditions here. So the only thing that is left is for us to calculate the delivery volume according to the delivery conditions that are given. Are we together? Yes. So let's use the formula that never gets old. V1 T1 wait, what's the formula? V1 T1 over P1. Wait, what's the formula? I gave you the formula. V1.
No, isn't that VF times PF
Yes,
times
yes.
VF over TF is equals to P1, open brackets V1 minus V4.
Okay, my head is starting with volume all the time. V1 minus
V4 all over T1.
T1. Awesome. This is the formula that you're going to use all together. Now, from the back, you can already see that this is becoming very, very easy. Before we even go ahead, you can see now that this is very, very easy. Okay, they want the delivery volume, which should be this one, the VF. Are we together? Let's play the mathematics. VF is equal to TF
P1.
O divided by
T1 PM.
Awesome. Okay, now let's put in the values now. TF is 15 degrees Celsius. 15 degrees Celsius converted to Kelvins. What do you get?
288.
That is correct. 288 multiplied by P1. What is our initial pressure that we're given? From the board, what does we have? 97. That is correct. And then the value of our V1, 10.647 times 10 to the power negative 3 minus V4, which is 2.324 times 10 to the power negative 3, close the bracket. All of it should be divided by T1, the initial temperature, which is given at 19 degrees Celsius, right? Let's convert 19 degrees Celsius to Kelvins. What do you get? 292 multiplied by PF, which is equals to 101.325. Are we together? Okay, let's get the calculating. What does we get?
7.859 times 10 to the power minus 10.
This is your volume. Are we together? This is the value of the volume. This is the free air delivery volume that they've asked you to calculate. Are we together? This is our free air delivery volume. Now, the next question is going to be a little bit tricky now, because they're saying calculate the volumetric efficiency. Are we together? The next question is saying calculate the volumetric efficiency. And the formula for volumetric efficiency, I think this is by far one of the easiest questions that you'll ever do. Because in some cases, they're not going to give you the diameter and the stroke length, right? That's our next question precisely, without the diameter and the stroke length. Okay, V1 minus V4 all over V1 minus V3. Are we together? Okay, so it's going to be, open bracket, 10.647 times 10 to the power negative 3 minus 2.324 times 10 to the power negative 3. All of it is being divided by, open bracket, V1 minus V3, 10.647 times 10 to the power negative 3 minus V3, which is given at 6.027 times 10 to the power negative 4. Okay, if you want to be lazy like me, right? I'm not promoting laziness, by the way. But if you want to be lazy like me, V1 minus V4 is equals to V2. Did you guys know that? If you want to be lazy like me, V1 minus V3, or I said V4, sorry. V1 minus V3 is equals to V2. So, yeah.
So, where is P1? P1 is 97 kilopascals. Then they just said 97. We didn't apply that 10 to the power 3.
10 to the power 3. Okay, that's a very good question. That's a very, very good question. Okay, because the reason why we did not add the times 10 to the power 3 to convert it to pascals. Our volume and our pressure, the SI unit is normally kilopascals, not pascals. Makes a little bit of sense. Sweat. What does we get? You can multiply by 100 to give us a percentage. What did we get? Yes. Mandisa, let's get the calculator. Caleb? 82.86%. Perfect. Perfect. Questions so far? According to me, I think this is easy though. I don't know what about you guys. What do you guys think? According to me, I think this is easy.
According to you, sir.
Yeah, but you know, I'm a flawed human. Okay, let's go to the next question, right? The next question says, what does it say?
Which one? C.
Number C.
See the air delivery temperature.
Calculate the air delivery temperature. Okay. Now this is going to be we're together.
Guys,
Once again.
Are we sure we're together? Okay, now this is going to be a little bit confusing, but I'm going to explain it, right? We've got free air delivery. Free air delivery is what we've given here. Are we together? And delivery conditions is V1 minus V4. This is delivery conditions. Are we together? Intake conditions is V1 minus V3. These are our intake conditions. Are we together?
Says it 6.644.
Where?
V3.
Yeah. 10.044. Oh, there's no over. That's the answer. It's supposed to be times 10 to the power negative 3, but I don't know how I forgot to put it.
Okay, and then for V3?
V3, we got 6.027 times 10 to the power negative 4.
No, I can't.
Which one? This one?
Yeah.
Oh, this one is coming from a lie, sorry. This one is coming from the previous
So
question.
it's 10,044 times 10.
Yeah, it will give us that answer. Okay, let's move on to the next question, right? We're saying free air delivery conditions. These are the ones that were given. Are we together? This part is going to be confusing in the final exam. So let's slaughter this part now. Free air delivery conditions are these ones that we given. Are we together? Then delivery conditions is V1 minus V4. Are we together? Intake conditions is V1 minus V3. Are we together? Yes. Let's look at the formula for efficiency. It's output divided by input times 100. Are we together? That's the formula for efficiency. This is our output, V1 minus V4. This is our input, V1 minus V3. Are we together? So in this instance, they want us to calculate the delivery
temperature.
I'm going to rub a few pieces off the board. I'm going to remove V1, V2, V3, and V4. Is it cool with all of us? Okay, so the formula that you're going to use, since it's polytrophic, yes, the formula that you're going to use, since it's polytrophic, we've got this polytrophic formula, P1V1 to the power n is equals to P2V2 to the power n. So this formula is not going to apply. So we're looking for the temperature. Can you give me the polytrophic formulas? There was someone who knew the polytrophic formulas with their heads. Was it you or you?
You?
Yes. Temperature.
Just goes to P. The one of P or the one of V.
P.
Yeah, it's P1, P2. No, that one is what? It's P2. It's T2 over T1. P2 over. Yeah, and
Sorry, is 1, this is 2.
Then n minus 1 over.
N minus 1 over?
N.
Yes. This is our polytrophic formula. Are we together? Yes, apparently it's the correct one in the textbook. I'm very proud of you. I'm very proud. He knows these formulas with his head. Okay, so T2 is going to be equal to T1 P2 over P1 to the power n minus 1 over n. Now, if we're going to do the mathematics, our T1 was given as 19 degrees Celsius, which is equals to 292 multiplied by P2, which is 600 divided by 97. And the value for our polytrophic index is minus 1 over 1.35. What does we get? What do we get? Questions so far. I think compressors are coming along nice and easy. Man, so you agree with me?
468.
It's
468.
yes, 468.33.
0.33 Kelvin.
This is our answer. Are we together? Oh yes, someone was asking me, do I need to convert this to degrees Celsius? And depends. In the final exam, there's no need to though. Unless they ask you. Okay, next question. Calculate the cycle power, right? The next question is calculate the cycle power. In as much as I love myself, I would have loved to just, break this formula down for you, but not today. Not today. I'm not gonna break this formula down for you today. Yeah, I would have loved to. Okay, I'm removing this part off. Did you copy this part? If not, let's copy it for 2 seconds, then we'll get rid of it. Then this question will be done. Then we'll do the next question that does not include diameter and the stroke length. The question will be calculate the diameter and the stroke length. Nice. I think I've already got, yes, that's the next question. Okay, is we done? This part. Just the free air volume. We done with it, right?
Mm-hmm.
Perfect. Let's get rid of it. I might need you now. Okay, now for our work done, we're going to use the formula for work done. Which goes to n over n minus 1. Okay. P1, then V1 minus V4, close bracket, then open bracket, P2 over P1, close bracket, n minus 1 over n minus 1. Okay, but then we are asked to calculate power. I want to get the question is asking us to calculate power. So we have to include the rotational frequency that is given. I want to get that means we're going to multiply it together with the rotational frequency, but not per minute though, because our rotational frequency is given at 550 revolutions per minute, right? We have to convert it to per second, since power is per second. Okay, so n 1.35 divided by 1.35 minus 1, and then the value of our P1, which is, yes, dead people, let's wake up.
97.
And then what's the value for my V1? Mine is gone, sure.
10,647 times 10 to the power of 30.
And the value for V4?
2,324.
Times 10 to the power negative 3 as well.
Yes.
Perfect. Okay, and then we open a bigger one. 600 divided by 97. Close bracket, 1.35 minus 1 over.
1,35.
Correct.
Minus 1.
Switch. But now we're looking for power, so let's not forget to say multiplied by the rotational frequency, 550 divided by. So this is simple, eh? Or is it just me who's too clever?
Oh, that's simple.
Listen to me. What does we get? Kilowatts. 1 point what?
1,551.
That's not correct.
So the textbook is wrong.
No, the textbook made a mistake.
You're saying the textbook.
Yeah, the textbook made a mistake. I think it was the typing error in the text.
But okay, let's quickly do it. 647.
Oh, you guys were giving me textbook answers all along.
No, it's just
okay.
this one. I thought we shall be right.
No, the textbook made a mistake. Instead of 550, the textbook is 500. Did you notice?
Yes.
Yeah. So our answers should be slightly different. Like I actually typed times 10 to 1 negative 3. I think it's better because I don't trust this thing. I think it might make a mistake.
No, it never makes mistakes.
Are you
I
sure?
I always use that one. Times 10 to the power minus 3.
I think the memory of your calculator is full. I can't remember. Oh yes, it does happen. You've never had a calculator saying memory full.
Memory full.
Each one is getting 5.
5. Someone else had 5. Yeah. Oh, you had made a mistake.
So which one am I mistake?
The correct one is mine.
The correct one is yours.
The correct one is man and man. Mazina, why not the same number?
Aye, man. You're right, the answer. Yeah, man, you
The
saw.
answer that I get is the one that I'm going to side with. Mandisa, what did you get? A lot of people are getting your answer. 15 point something.
You must put it in brackets, right?
Yeah.
Don't just type it.
I'm putting it in brackets, don't worry.
Mine is
A lot
correct.
of things can go
Because
wrong.
they also have if.
Mine is correct.
Hey, when calculator me go, I said
A flash.
17.1.
Yeah.
I got to fail.
I said
The correct one is mine.
so new.
I said to fail.
Never mind. What did she
What
get?
the answer say? Say, you need to answer.
1.88. I'm getting the same one as she got the last time. Yeah, let's put 15. The calculators was. What did you get? 1.88 something. Well, let's just go with the
Before
thing.
you could multiply with 500 divided by 6. Yeah.
Oh yes. If you multiply by 550 divided by 6, what did you get?
You see, first you get the 1.8.
Uh,
First you get, let me quickly.
okay, because I didn't multiply.
First you get 1.8.
No,
right?
you calculate
And then you say answer.
Yeah.
Multiply
The answer will be in kilowatts.
by.
You're getting 17 as well.
Yeah, it's 15.
Yeah, it's 17.
15. Oh,
Let's just choose one.
Well, let's choose one. Man. I think I'll go with the one that Galvin got. I think I got it previously. Huh? Because it just makes sense, right? 55 divided by 6 multiplied by 1.88
Yeah.
shouldn't give us 15. It should give us more. 1.88 times 55 divided by 6. 0.88. Yeah. Multiplied by 55 divided by 6.
Yeah, we'll see in the exam which one gets the correct answer.
6.
Now mine is correct.
We'll see.
Mine is correct.
Let's see it.
It's the correct answer.
Awesome.
You can get 17, 15, but mine is
17
correct.
15.
Nah, this is the correct one.
667.
By majority votes, I'm sorry, sweetheart.
If you say 1.8.
Can you stop it for me? Can you stop it for me? Then we'll start it.
A minute at 103 kilopascals and 15 degrees Celsius.
That's what?
103 kilopascals and 15 degrees Celsius. The delivery pressure is 700 kilopascals and the speed is 300 revolutions per minute. Assume the clearance volume is 5% of the swept volume with a compression index N is equals to 1,3. Calculate the swept volume of the cylinder in cubic meters. Calculate the delivery temperature of the air and the power required to drive the compressor. Assume R for air is equals to 0.288 kilojoules per kg Kelvin.
Let's look at this question for a little bit. This question has introduced the value of R, right? That means instead of that formula that we used before, we say is PF VF is equals to TF, right? You can rather use this one. PF VF is equals to MRTF. I think that's the reason why they gave me this thing. So I want you to go finish studying up this question. For today, I just want us to study up. I just want us to calculate V1, V2, V3, and V4. That's all, right? So the rest of the stuff, since we've already done it before, right? So it's just going to be a copy and paste method. Plus you have solutions on how to do it now. Okay, so let's start. The very, very first thing you start with is your V1, your V2, your V3, and your V4. This is the starting point. Are we together? V1, V2, V3, and V4. And what is the value of our V2? Since it's not given, it's SV. Are we together? This is the value of our V2. And what is the value of our V3? The value of our V3 are 5% of the swept volume, right? So which means it's going to be 0.05 SV. Are we together? Does it make sense? You can calculate volumetric efficiency without knowing these values. Okay, next question. Next point. Let us calculate the value for V1. So V1 is SV plus 0.01 SV, which is going to give us. Thank you, Charity. That's true. Okay, then let's go to the next part as well. Let's go to the next part. The next part where we'll have to calculate V4. So the value for V4 is 0.05 SV multiplied by the value for P2, which is 700 divided by 103, sorry. To the power 1 over 1.3.
Sir, when you have V1, 1.05, what do you do?
Where did I get it from? Okay, that's a very good question. Where did we get 0.01 here? Galvin?
Wait, what? Wait, did I give you up?
Yeah, where did we get 1.05 SV?
Yes, sir.
Yes, Galvin?
Is V2 plus V3.
But V3 isn't it 0.05 SV?
Yes.
Yeah.
Plus SV.
So we add the SVs,
Yeah.
they give us 1.
Yes. That's correct. That's very, very correct. That's very, very correct. So here you're going to perform your calculations, right? And ignore the SV. So your volume, you're going to look at it as 0.05 and then 700 over 103, 1 over 1.3. And then when you get your answer, they need to be whatever that you get SV. Are we together? I hope that makes a little bit of sense. Yes, calculators, let's get the calculating. Can I borrow your book?
So SV plus SV is 1.
Yeah, SV plus SV is 1. So 0.05x plus x, 1.05x. So yeah, you can choose if you want to use SV or x. The textbook tried to use the table method, but you can do whatever feels natural to you, okay? You can do whatever feels natural to you. You can either use the table method if you feel comfortable with it, right? Where you have to calculate P1, P2, V1, V2, but Whatever feels comfortable to you. What did we get here? Calculators? Govern. Well, I mean, Caleb. Sorry. I don't know how long is this going to last me confusing you. Where is your calculator? Payday. Today is 28, isn't it? Today is such a beautiful day.
It's not yet payday. I want to.
When is payday?
The day after tomorrow.
Huh?
The day after
31st. The very, very last day.
Exactly.
All the promotions will be finished, very.
What promotions?
Promotions are month end. You don't know that?
Well,
The sales. They'll be finished.
but it's not.
What did we get?
0.24.
Okay.
0.08.
0.24.
0.024.
Yeah.
Mandisa, where did you go wrong?
I'm supposed to substitute some kind by SV.
Yeah, sir. That SV is a problem. You said SV plus SV is one SV.
Yes.
And then
that's it.
SV plus SV is 1 SV.
and then x plus x is one.
Oh, you're saying 1 plus 1 should give us 2.
Yeah.
Oh, so 1, SV plus SV should be 2.
Yeah.
Am I getting you correct?
X plus x is
It's 2x,
Yes.
exactly. Yes, I think I'm getting you correct.
SV plus SV is 2SV.
Yes, I think I got you correct. Okay, now remove the SV and put x. X plus x plus 0.5x. What do you get?
X plus what?
0.5x.
1.0.5.
1.5x. Right?
So
Yeah, 1 point. Yeah.
okay.
It's making sense now.
So say it again.
Okay, let's remove the SV and let's put x.
Yeah,
Right?
let's put x.
X plus x.
2x.
Correct, right? What about x plus 0.5x?
It stays so.
What do you get?
Wait, say.
What
no,
should be
please,
the
please, please.
line so.
That is 0.218 SV.
It's 1.
Okay, let's write it down, then I'll get you
218 SV.
0.18 SV, yes. Okay, let me answer your question, Kelly. And you. So the question is, why are we getting... what did you get?
What's before?
What's before, sir? Say those 0.05.
Yeah, 0.05 SV.
Yes.
And then open bracket 700 divided by 103.
Share me a bed.
Yeah.
Sir.
Okay, wait, let me answer the question. It's your question as well, right?
Yeah.
Yeah, let's go to the maths.
You
X plus x,
2x.
2x. X plus 0.5x,
Yeah, that's the 1.05.
Thanks.
1.5x, right?
Yeah, 1.05x. Yes.
Okay, so here it's 0.05 plus
Plus
1
nothing.
plus SV.
Yeah.
Right? So you can look at it this way. Or you can look at it this way. I'll come to you. You can look at it this way. Remove SV and put 1. Remove SV and put 1, right? Can you do that for me?
Oh, yeah.
Okay, substitute SV for 1. So it will be 1 plus 0.05. It will be 1.05. Now it's making sense now.
It's like the.
Yeah, I get you.
So I need.
So
Units.
one big grade as units.
Yeah. Wait, let me finish with Caleb, then I'll get to you. I want to make sure you're satisfied. Then I'll make sure you're satisfied. You're satisfied, sure. Wait, look at this one laughing.
Well, you're gonna multiply it with 0.05.
Yes.
Multiply it with 1 multiplied by 0.05.
Yes, that's correct.
Okay.
Yes, that's very, very much correct.
Now
Yes.
it makes sense.
Yes, nice making sense. Who else had a question? Manzi?
Are we supposed to substitute raised
No.
road SV?
No, don't
So
substitute.
is this what I was supposed to do? 0.05.
Yes. But you made a mistake though. You said 200 instead of 700.
Oh, it looks like a 2.
It looks like a 2. Oh, come on, you've given us got this flamboyant thing that is flying.
Flamboyant.
It's Okay, now let's move on from here. Now we've got the values for our V1, our V2, V3, and V4. You got a different answer. Okay? Calculators are calculating. Yes, you made a mistake. You said 0.055. Yeah.
It's that's what I did.
Yeah.
I said 5.
You said 5. Yeah, I've noticed that one as well.
Your S and your 5.
They look the same.
Ah,
Okay, let's finish this one, right? Let's finish this one. Let's finish this one, then we move on. Okay, let's finish this one. Now, the question wants us to calculate, wait, where is the question? Calculate the swept volume of the cylinder. Calculate the swept volume of the cylinder. But they have told us that this one is a double acting cylinder. Are we together? That means that the volume that is being delivered twice in one cycle. Are we together? Twice in one cycle. That means you'll have to multiply by 2. Okay, now the delivery volume is equals to V1 minus V4. Are we together? This is the volume that is being delivered. And we are given, I think I wrote it down somewhere. Yes, we are having a delivery volume of 14 cubic meters per minute, right? So we need to find out per each cycle or per second how much volume are we sending or how much volume are we receiving. So it's going to be 14 divided by 300 because it's 300 revolutions per minute. Are we together? Yes. Is it making sense? Yes. What do we get? 14 divided by 300.
Now wait. What's making sense?
So,
Okay.
the last one
Yes.
until convert.
2 per second. Okay. Okay.
Sorry to take you back, but why didn't we calculate V2 using this formula? Because like in the previous one we calculated it.
Using this formula. That is very correct. But they did not give us the diameter and the stroke length.
So if they didn't give us this, then we just assume that it's 1.
No.
We're just going to assume, no, not exactly assume. We're just going to substitute the diameter for D, and then you substitute the stroke length for L. And then the volume, you substitute the volume V2, you substitute it for SV. You lost. Okay, so this formula will be exactly equal, right? And this volume will be exactly equal. But instead of now you using the actual numbers here, you're just going to put SV. Yeah. And then, so that if the question comes and says calculate the diameter, of which it does on most cases, if it comes and says calculate the diameter, you will have already have your volume there. Makes sense now, does it? No. It's a lot to take in. For
Let's
the
go
first
back
time.
to the 14.
Yes. What do you get? If you say 14, if you say 14 divided by 300, how is it?
0.
You get?
0.
0.4.
0.04.
0.04.
0.047.
0.07. But then this is double acting, so let's divide this 0.047 by 2 again. What do
You
you
don't
get?
multiply by 2.
No, we're dividing it by 2. You multiply by 2, so you can multiply the 600 by 2. Since per each stroke it's working twice.
Okay,
What I'm saying is that we need to divide this volume by 2 since it's double acting.
and then you're gonna get 0.023.
Alright, no problem. You want it now?
Sir, I didn't sign
I'll
nothing.
bring it. I'll bring it.
Sir, I didn't sign nothing.
Oh, wait, it'll come. It'll come. Okay, let's finish this thing. Monkeys in the back. No, I'll give it to you. I brought it for you.
0.023.
0.023.
Yes.
Okay. Next up, now we need now to now substitute, right? Because we've got the volume that is being delivered. So now let us substitute. I had no idea why they were giving me the answer like this. Who? Yes. Can you convert it to times 10 to the power negative 3? So I can be a little bit closer to the answer. 23.33.
Yes.
Alright, let's just put it like this. Okay, now this is done. Remember, V1 minus V4 is equals to 0.02333. Are we together?
I meant like
From the minutes.
seconds.
From minutes to seconds. Now there's no need, right? Since it's per minute, so the per minutes should divide each other out. Like the SI units for minutes will cancel each other out. Makes sense? Okay, so he's going to be, hold on just a little bit, it's almost done. It's going to be 1.05 SV minus 0.218 SV is equals to 0.0233, right? And if you have to do the mathematics, what do you get there? Yeah, let's do the mathematics this side first. It's V1 minus V4. So let's do the mathematics this side first. What do you get? It's 1 comma?
Wait.
0,832.
The final answer.
No, here. You got
0,832.
832
SV.
as V is equals to 0.0233. Then you divide both sides by? By the way, make sure your presentation is
0,028.
0.028.
Somewhere crazy, lose myself in the
Are we together?
lights. I just wanna go there tonight. Somewhere different, lose myself in the lights.
Yeah, hush, baby. So how you doing, honey? With me, you know there's no losing, honey. I ain't bragging, but got plenty money. Spending it as if it's funny money. I know you've been at your 9 to 5. Let me put something new in your life. Bottles and models and skipping lines. Tipping them strippers that lavish life. Take a private jet from here to LA. Hit up London and y'all insane day. Let up Vegas if something go dumb in the bed. Pop a couple bands, shut down every state. Would you believe it? If I were to, I'm the man to change your life. Would you believe it? If I were to show all your dreams in just one night. What if I told you that you could have all this cash? Not just today or tomorrow, right now, girl, right away. The best time you've ever had, it starts and ends with me. Would you believe it if I told you that? Ain't no illusion, honey. I am the realest girl you know about me. You ain't just out here with anybody. All I do is exclusive, I own the party. You think you sitting courtside? Don't kill up on a high five. Shawty, you can say the sky high. We're going private for the mile high. Girl, I can show you things, so tell me.